Attention, please. The show starts in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go.
Good evening, everyone. I warmly welcome you all to this exciting and insightful event. The IEEE Consumer Technology Society and Computational Intelligence Society organized technical talk on next generation AI in healthcare. Before we begin, let me briefly introduce myself. I am Arundhati Chaudhary, a third year CSE student and a proud member of IEEE. I am absolutely delighted to be your host for today's session. Now, before we move ahead, let's take a moment to appreciate the power of the topic we are here to explore today. In healthcare, AI is transforming how doctors diagnose, predict, and even prevent diseases in real time. From explainable AI that helps us trust machine diseases to federated learning that keeps patient data private yet powerful, and now generative AI, which can create synthetic medical data and design personalized treatment plans. The possibilities are breathtaking. Imagine an AI that can learn from hospitals around the world without sharing a single patient record, or one that can explain why it made a particular diagnosis. That is where the next generation of healthcare technology is heading. And today, we get to dive right into the future. To take the session forward, and now request Dr. Niranjan Kumar Ray, Assistant Professor at QT University, to officially welcome our esteemed guest for the day, Dr. Ashok Kumar Pradhan from SRM University. Yes, sir.
Good evening to all. This is a great pleasure for me to introduce Dr. Ashok Kumar Pradhan, Associate Professor from SRM University, Amravati. Uh, he has done his research in wireless networking as well as in data science. This topic is a very interesting topic. I hope all the audience will interact during the presentation. And whatever is query, you can address and ask during the presentation. And if anything is more beyond that, you can have a offline interaction. Now I invite Dr. Pradhan to present the topic. Thank you.
This is like
Before there is a small
okay. First of all, thank you very much. Thank you very much for such a wonderful introduction, and good evening all of you. So as you see that my talk is related with the next generation AI in healthcare. So already one of a student of third year has given a brief introduction about how healthcare is important in day-to-day life, and when these eras, healthcare is one of the very important issues. And here we will discuss about everything in healthcare, like as the day passes, the data has been generated is in a like in a huge, how we can able to use the AI techniques to handle those data, and we will maintain the privacy as well as the security, so that we won't face any kind of hazards in our life. So this is like real-time application with explainable AI, then the federated learning and the generative AI. So the main contents of this talk is all about like what motivates the role of AI in healthcare, what are those applications, we will see like what are those applications of AI where it contributes, and finally we'll see like the conclusion part. So in between, I just want from your end also, I know many of you students are from the third year or final years, mostly from third year students, and they are doing their projects like in their third year, a capstone project or like industrial project, UROP project. So this talk will definitely help them to get a knowledge, and they can able to get these ideas to implement in their projects. So I'm not going into the very details about the project. I will just explain you overall, like how we are using those techniques in our healthcare application. So first of all, the motivation. Okay, thank you, thank you. So what are the challenges in a healthcare system? Yeah, already I have discussed about it. Let me repeat again. So growing patient data volume and complexity. As you know, the size of the data set has been increasing enormously, and it is very, very difficult to handle those data set. Need for faster, accurate and interpretable decision making. So how we can able to handle those data set is a challenging issue. And the last but not least is very, very important, the privacy. So privacy and security is one of our major concern to handle those data set. And why AI matters? Automates analysis of medical data. We need not to process the data manually. That's why the AI comes into the picture, so that the things should be taken place automatically with the help of the those expertise techniques. Supports real-time diagnosis and monitoring. So as you know, nowadays you can see in a healthcare, we are using the robots, okay, and other the machineries which can able to diagnose the patients. I hope all of you are aware, during the COVID time also, you have seen in the, like in China, I hope you have seen. So when the human are not able to reach, we are sending the robots who are already been trained. Definitely they are AI trained, and they are reaching to the patients, and they can able to provide those facilities. So they are taking care of in each aspect. So providing the medicines, as well as they can able to diagnosis, provide the medicines, and they can able to get the report, and they're also able to analyze those reports also. Okay, and so this is called supports real-time diagnosis and monitoring. So the doctors need not to reach, okay, there. So by using the AI tools, they can able to diagnosis, and even if the doctors are not available also, we can able to do the treatment. Can you please tell me one example where even the doctors are not available, we can able to do? As I told one example, the robots nowadays are available, we are making them the trained, and AI is already fitted into that, we can do it. The another technique I have not explained here, that is called digital twins. How many of you are aware of the digital twins technology? Yes, may I know, like, how the digital twins works actually? This is a very important feature in our AI healthcare. Okay, very good. Yes. So in this scenario, what happens? We want to create a replica of our model. So let us suppose someone is having a heart issue. Okay. So in this case, what happens? He will create the doctor will create a replica of an heart, and he can able to find out what is the problem in that, and then he able to diagnose that this one, like the virtual one, and that can be also implementable for the real person. So in this case, what happens? The error, the main objective is like the error part can be reduced, and the secondly, if a doctor cannot able to reach in a particular place, so someone can able to treat the patient. So this is another application in the real time. Enhanced treatment, yeah, personalization. So this way the treatment would be more better, and it will be give more accurate. Okay, now the role of AI. So I want to discuss few things about the role of AI. So as you can see, first we'll talk about the machine learning and the deep learning, where pattern recognition in large data set. Already we discussed, like we want to find out for healthcare, the day by day the data set has been increased For machine learning, we are using the data sets which are all of numeric text data set, and for the deep learning, we are considering all about like the image data set. But that number is also increasing abruptly. Then explainable AI, making AI decision transparent and trustworthy. So this is very important. By using this explainable AI, we want whatever the decision has been generated by the AI, your explainable AI put say yes, it is your whatever your prediction, yes, it will say the accuracy of your prediction, how much accurate it is being, whatever you have been predicted. So let us suppose someone is having diagnosis with the cancer. Okay, so now by using this explainable AI technique, we can able to detect, yes, whatever he has been predicted, how much accurate the prediction it is being. So that case we can talk about the explainable AI. Then the federated learning. How many of you know about federated learning? May I know like how many of you have little bit idea about the federated learning? Like what is the federated learning? No one? So if you are not aware, anyone like FL, it's a very important. I'm just telling you now, if you're writing any research paper or any sort of project, please work with the FL, because I have done like last 2 years, we have like published 4 to 5 papers in FL. If you are in communicated, only one simple thing is that why FL? Why we are talking about FL? So as I have told in the beginning slides, where like you cannot send all your data information to another network or to a server. Okay, so whenever you send a data, it should be encrypted format. So those students who are like know about the encryption and decryption, that will be helpful for them. So you must have to know that whenever I will send my data, okay, to suppose I am a client, I am sending a data to the server, and then my data needs to be, it is in an encrypted format. Then how the huge amount of data can be sent in an encrypted format? Very simple. So I have created my own model, train my model considering the data, and then what happens, I have to generate a encrypted weight, okay, only to the server end. So like me, all the clients, they also need to send the encrypted weight to the server end, and server also train this model, and then they process those, and then they will return back the model that is called the global model. So server end we are calling it a global model, and at the client end we call it a local model. Okay, but they will generate the uh, weight, okay, which is an encrypted format. Rather than sending all the information, it only generate from the local model and send into the global model. Global model will twin and then will return back. I have a different slide for that. So secure collaborative learning across hosting the raw data. This is very important. They are not sharing the raw data to the server end. They are only sending the encrypted weights data. So this is a very important technique. Nowadays we are using to train our model. So you please think about it. Explainable AI. Next is the generative AI to generate descriptive explanation and interactive conversation. How many of you are aware of this? Can you please tell me, like, anyone has having idea, little bit idea about the generative AI? You people are using AI, fine. Very good answer. but I just but can you please little elaborate? I didn't get your answer actually. Mm-hmm. Yeah, can you give me an example for that, like where generative AI related to healthcare or some any other application? You please try to understand when I'm talking about healthcare, because I have done most of the papers with the healthcare. You can work this agriculture and line, because as you know, all of you are aware of, you have an idea now where this idea is fitted. So I found this idea is very fitted with healthcare, and healthcare is booming, and that's why I fit into that and getting the good response. Now the generative AI is simply what happens. information means. Suppose I uploaded an image and I want to know what are the kind of diseases it is having. So it will go into very details in the next slide. So we'll go one by one, start with the machine learning, deep learning, explainable AI, federated learning, and the generative AI. Okay. First, as I told you, machine learning, we have worked in a paper that is called, I hope many of you have studied this, a very common disease like kidney disease prediction, and diabetes also there. But we have chosen like the kidney disease prediction, diabetic, heart disease prediction. Okay, these are very common, and other domains are also there. So this is a very good domain capstone project. Many of the work has been done. But what extra we have done here that I will explain in this work is your online integrating CNN and explainable AI. So this is all about our next work, CNN and explainable AI to enhance lymphoblastic leukemia. So we are trying to find out leukemia. I hope you understand. This is all about a cancer. There are different kinds of yeah, categories in a cancer disease. So one is called leukemia. Fine. Next, we have taken federated transfer learning for the chest X-ray images. So here we are talking about X-ray images. So first one is the kidney disease prediction. This way it won't work. Many BTech students they are doing. They have just taken the papers, their implementation results to their paper, and they want to showcase. So please don't do that. And due to the black box nature of ML model, it is difficult to explain why a model makes a specific prediction. So by using the ML technique, we can able to predict it, like whether it is having a kidney disease or not, means like it is 1 or 0. Okay. Now, so that we have predicted, but after that, the explainable AI will tell whether whatever you have been predicted, is it true or false. So that's why the explainable AI comes into picture, highlights key features influencing predictions. So it will highlight the key features. Based on that, you will say your prediction whether it is correct or wrong. So we have understood till now, many of you have done, I think, ML, different algorithms you have been used, and you have said like, sir, we have get a prediction, or the accuracy we are getting, sir, 97 or 98%. But the explainable AI after that will tell you whatever you have been predicted, whether it is correct or not, means how much it will be influenced. Generates visual explanation for clinicals, and also it will generate the visual clinicals. Like, I'll go to the next slide so you can understand in a better way. So you can see the ML. I hope all of you know about the ML, how we are taking the data, then we are pre-processing the data, then we are, after pre-processing, like we are taking the data in the form of numerics or text, then we pre-process the data, then we are trained and testing. Pre-processing, we can do it by so many existing ML algorithms, and now we are also combining the few algorithms also. I hope you know about different ML existing algorithms. Then we are splitting into two set of data, training and testing, then model training, and after this we are going for hyperparameter tuning and the model training, and then finally we are going for evaluations and get the results. So this way we are getting your ML. But now ML entire process I have told, training and testing, all of you know, like it is split into 80 and 20. 20% is for testing and 80% is for the training the data set. Now explainable AI, this is the black box model. In the previous we have discussed, like we will say like whether it has been predicted, whether it is having like kidney disease is there or not, the instance being explained. So it will explain your black box model. Fine. So what are those techniques? So in the explainable AI, so as I have told you, it will explain exactly you are having, okay, or the disease which you are having, okay, or the disease which have been predicted. You can see the explainable AI techniques. There are two techniques. How many of you know about SAP and LIME? SAP and LIME. Anyone? Explainable AI here. Very good. So you should know. After this, you need to know this one, so that you not to be strict only with the ML. You'll go accepted if you can integrate one or two techniques. So ML we have done positive, or it is diagnosed with a negative. So can explain both local prediction and global model behavior. So one is the SAP. Then LIME the full form is local interpretable is the SAP. Then LIME, the full form is local interpretable model agnostic explanation, explains individual prediction of complex models. So it will go and explain the complex model, approximates the model locally with a simple interpretable models, highlights, this point is important, highlights which pieces contributed most to a specific prediction. So it will also give you highlights the value, and based on those value, it will predict, like if some attributes having more values, then it will be yes, it is like having diagnosed positively. So we will see this when we will implement. You can see here hemoglobin. So you can see class 0 and class 1. When we implement this one, we can find this one. Which one is contribute more? You can see hemoglobin is getting more, albumin, then blood urea, specific. And slowly you can see force plot for CRD negative prediction. So how you can see here, you can see this is minus 12.29. That means the contribution of this attribute is very minimal. So that means it is predicted as a red. You can see that predicted it is negative kidney disease. That means negative CRD. Similarly, here you can see there are parameters like blood glucose, red blood cells, blood pressure, blood urea, albumin. This is having more contribution. Okay, more contribution means it will be diagnosis as a kidney disease. So earlier we have seen that by using the only ML algorithm, we can able to predict, but how much your prediction is correct, that we can understand from this SAP model. So here it is less contribution, means you can see these attributes. Less contribution means that definitely act on a different attributes. Okay, each of the data set consists of different attributes. I hope you understood. I have not discussed about those data set. I just discuss about the attributes. So you can see, so attributes is less red color, you can see that means it is negative, but here you can see red means it is more like a positive. So it is diagnosis with the kidney disease, okay, by using this SAP model. Now similarly, you can see the live, the first one you can say all of our, it is like CRD positive, CRD positive, CRD positive. That means CRD negative is 0.08 and the CRD positive is 0.92 from the previous diagram. So what we have concluded, line plot for this, it is diagnosis is a CRD positive, and here it is more means it is all are positive, and it is negative is 0.94. That's why it is predicted as a CRD negative. That means here very less chance of kidney disease, but here it is more. Okay, so these things we can understand with the help of your explainable AI. Now just wait. So I hope this one is clear. SAP, so explainable AI techniques, please go ahead for a SAP and LIME. So that will help you to addendum to your machine learning techniques. Okay, please use those techniques and you'll get lot of ideas, and your Gemini 2.0 or 2.0 and the Chat GPT also will help you to generate this kind of results. Okay, now we talk about the deep learning. So the first one, we have taken the data set which are in the form of text data set, and we have discussed about the kidney disease prediction. And this is all about explainable AI, and here first let me talk about like DL, then I'll go into the explainable AI. So DL is used to deep learning, deep neural networks. So if you have studied ML, next is the deep learning, and where we are talking about the images, fine, and it needs more huge amount of data set. It's not like in case of your ML, if you take 3000 data set, it's fine, 5000 it is fine, but in case of here in the deep learning, you have to take like the 50,000, 1 lakh, 1.5 lakhs, even 2 lakhs. Okay, so huge amount of data, and that's too they are in the form of images. So to process those things, we need a very good machine. So those you are having like a DGX, how many of you know about DGX? How many people? NVIDIA. Now, if you understood. Okay, DGX NVIDIA actually. Uh, so it needs when you need to process your data, train your model, it needs a huge processing time. Okay, and for this we need to do your simulation with a simple system, or even if it is the workstation, it is difficult. So we need to use the DGX. All our simulation in case of deep learning, we are using DGX server, NVIDIA server. Okay, and this cost is around 2 point some crore CRO. Okay, now I hope the kit is having that facility. Sir, DGX server is available? No? So you please request to your so if you have first step to understand DL, then you have to implement. Fine, it's very interesting. So black box nature, difficult to explain why a model makes a specific prediction. So that I have shown in the ML model also. So when you are predicting it, you are not sure like whatever I am predicting, is it correct or not? So that's why the explainable AI comes into the picture, and I have talked about the SMOT and LIME also. Now, what is the data augmentation? So now you can see data augmentation creates synthetic data from the existing data. So sometimes what happens? What is called synthetic data from the existing data? Can someone please tell me like what is synthetic data? Hmm? Yes. So sometimes what happens, why we are doing it, that is important, because we have a data set, and what exactly we need for our experiment, it doesn't fulfill. So we need to generate the synthetic data for this. Just we want to create a replica of our own data set. That is called a synthetic data. Okay. You are not able to get it, because to get the healthcare data information is very, very critical, because there are various countries, UK, US, they are not sharing their health related data information, and whatever we are getting our data, the data set from Kaggle and all, that is also not huge informations, because if you are working with a particular say a domain in a healthcare, let us say about heart disease or kidney disease or some other disease, you can say somewhere you are not able to avail the actual data set. So in that case we have to create the synthetic data from our actual data set. Okay, that is called data augmentation. So that is, please remember, what do you mean by data augmentation? Okay, so XI generates visual or textual explanations for the clinical. It is augmentation takes place for both the image as well as for the text data sets. Now, so yeah, I just given an example of data augmentation which we have done for this linear disease prediction. So you can see how we are doing technique, data augmentation. We are just rotating by 10, then horizontal flip, height shift, width shift. So this is the actual data, okay, image. So we are doing it different kind of horizontal shift, vertical shift, left, then right, then shear, vertical flip, zoom, brighten, contrast, saturation, random crop, and Gaussian noise also it is there. Please remember. I hope you have some idea about the Gaussian noise. So with this we are creating the synthetic data by rotating it and by horizontal flip and all these techniques. Okay. Now you can see line for image data. So we have talked about the text data. Now we will talk about the image data, how it behaves, the explainable AI here. So explains prediction of complex image models by CNN model, perturbs the image by masking the segments and superpixels. So we are as you know that images are consisting of different pixels. So we are perturbs the image, like we change the different angles. Okay, observe the changes in model prediction for these perturbations, fits a simple interpretable model locally to approximate the decision. So in this way we are getting a local model and highlights the image regions that most influence the model's prediction. And by doing all this hit and trial method, we are getting we are highlighting the image regions. Okay, and the line provides visual explanation by showing which parts of an image contributes most. So now we do all this process, and after this we can see just wait, which image is being highlighted. So this is actually model architecture which we have proposed, and you can see input the image, resizing, then data augmentation techniques we have done, and this is all entire part of the CNN model we are doing. After this, we can see these are dropout layers. This is important. We can see that the in CNN different layers are there. We will drop out those layers which are not important. Okay, we'll discard those. And dense layer 4, you can see these are different categories of your this leukemia disease: benign, early B, pre-B, and pro-B. Okay, and then this medical predictioner will predict whether it is benign or early B or pre-B or pro-B. But whatever he has been predicted by this, the doctor or the medical predictor, whether it is correct or not, can be explained by the explainable AI. So here you can see by using this explainable AI. So here it will goes the image by using this line, surrogate the model generation, then identifying the reasons of the interest. So he will identify which region is having more contribution. So it will find that this region is more contributed. Based on these reasons, he will say whether it is having early B or pre-B or benign. So in our case, it is being considered as a early B, because we will have, it has been identified, yes, it is having some disease, but which one among these 4B can be explained by the your explainable AI. Okay, so this is the model flow, the same thing which I have discussed, same here it is written. Then working of the CNN model, this talks about this CNN model, how it has been worked. So this is like conventional layer, max pooling layer, and global average pooling. So these details are there, how CNN is working. So please go ahead, I will share this PPT with you. Now same here, flatten layer, dense layer, and dense. Now you can see pre-B, this is the existing image, and we can see line visualization of pre-B. So pre-B, the disease has been predicted as a pre-B. So we will have all these 4 stages. In this, we will find that it is having the pre-B disease. Okay, by using the line, we train this model and we can able to predict that it is having the pre-B. So before that, we will go with all these 4, but we are not able to predict which one is this. So by using the explainable AI, we can able to diagnose that it is having pre-B. So this is the difference of using the explainable AI in your healthcare. If you are not using this one, you will be like in this stage only, up to here only. But when you use the explainable AI, by using the line, we can able to predict, yes, it is having pre-B. Okay, so yeah, now, so these 2 things, we have talked about ML with explainable AI, and we have talked about Lime and Smart. Next, we talk about, then we talked about the CNN model. I have not gone into details about the CNN model. Please go ahead. And then we talk about like how the explainable AI help in the CNN model to predict exactly what disease it is having. Now we talk about the federated learning. So federated learning I have discussed, but how it is being worked here, you can see here the global model is there and there is a local model is there. So the global model will do data aggregation, send it to the client model. The client model will train the model, and it will revert back their model to the global model, and this process will be keep on repeating. But internally how it is happens, instead of sharing the entire data, they always share their model weights. Okay, and to maintain the privacy and security, the same thing has been done. So in the very beginning I have told, the third case we have considered about chest x-rays. The first one we have taken about the renal kidney disease prediction. Second one we have discussed about which one? No, second one we have talked about leukemia. The third one we are talking about the chest x-rays. Okay, here we are integrating FL technique also. So here you can see, as I have discussed in the previous slide, we have like a local model is there, and the global model is there. The global model, okay, global model will share their weights to the local model. Here, the previous slide, yeah, here you can see the global model share their this model. They always share their model. Please remember, model only they are shared in the form of weights to the local model. Local model from the local database, got the data, and they train the model and share their weights to the global model. And this process will keep on train for 10 times or 20 times until we are getting a better model. Okay. So this is very important in case of your FL. So how it is different from ML and DL, then we are coming into the FL, that you should understand. So how the CNN comes into the picture, we are talking about the local model, we are talking about the global model, and how local model in the client end interact with the global model from the server end. Okay. So here we are talking about a chest X-rays. You can see pre-process the data, and here you can see the pre-trained CNN by using the transfer learning, fine tuning, and then fine tuned CNN, and they are sending into the central server like global model, and you can see sending the copy of the fine tuned CNN to all the clients. So the previous slide you can see similar to that, they are sending their copy to the client's end, and each client trains the model with its local data. Okay, and they are sending into the central server. So this process is repeatedly taking place. After this, what happens, we are talking about this extra is this one, we are talking about the explainable AI. By explainable AI, it will be better visualization, and then Gemini 2i. So we are talking about visualization is better by using the explainable AI, we can able to predict it, and the visualization is better by using Gemini 2.0. Then explanation, whatever the disease, is done by Chat GPT. So you can see we are using the Chat GPT because sometimes the disease prediction we can take help of the doctors as well, but we are not able to get the doctors, so we are taking the help of the Chat GPT. Okay, so here you can see the same thing whatever we have done, data pre-processing, use transfer learning for fine tuning, then we are doing fine tuning, then FL training, same here, the same whatever has been explained here is being written here only. Then you can see this example, the Lyme visualization viral pneumonia. So by using this what chat gpt Gemini 2.0, we can able to predict, the Lyme can able to predict, yes, where we have a COVID. So you can see we can able to predict like where we have a COVID symptoms. So, okay, and now we are giving it to the Gemini prompt. Okay, by using the API, we'll give it to the Gemini. So Gemini, we will say you this, like you are a medical image expert, analyze the highlight regions in this chest X-ray, based on the highlighted areas, predict the most likely conditions, possible classes. So it will give you these results. Okay, then GPT-1 and GPT. So sometimes what happens when you are giving some query to the GPT, so it will also GPT Gemini, what happens, it will give different, for different image it will predict different. Okay, so here it is saying pneumonia, and here it is showing COVID. High score, that means it is completeness, correctness, and faithfulness. If it is more, then we can say yes, it is having COVID-19. But if it is less, you can see 3, description is valid, but clinical reasoning fails to correctly differentiate COVID from viral pneumonia. When we are getting 3 point, okay, in that case he is saying yes, it may have pneumonia, but it is not able to diagnose whether it is COVID or not. That means what I have to say, based on the values, we can able to predict whether it is pneumonia or it is having COVID. Okay, so it will correctly, when you ask this to the Chat GPT, based on the results what you have received, it will correctly predict the completeness and the correctness and the faithfulness. Okay, and based on that you will get these reliability values. You will take the completeness value. If it is more, then we can say yes, it is having this reliability value is more, means it is having predicted that it is having COVID. Okay, now yeah, so the previous sections were discussed all about like how FL comes into the picture, and now we will talk about like generative AI. So nowadays you can see that we are using this VR for adaptive stroke rehabilitation. So now we can see that, yeah, very good example that I want to demonstrate before you start with the generative, virtual reality. So how many of you are aware of virtual reality? I hope you, when you went to the mall, you have seen the people have put some headset and they are enjoying. So yeah, you are watching movies, huh? VR we are using for watching movies only, but Nowadays, VR can be used for various applications. Now you please tell me, sir, where we can use it? XR? Yeah. We are talking about VR now. So now, in case of, okay, how we can use VR in healthcare? As you know that when we are, suppose someone has been stroked and some part is being paralyzed. I'm just giving an example. Then what happens when you went to the hospital? They will do some normal treatment. The doctors will do some traditional treatment, okay, physiotherapy and all, fine. And this is repetitive. Every time there is some schedule is there, you have to go and you have to do, okay. And the improvement and all you have to tell, but he has to do the same kind of, there is no change in the process, isn't it? Like, you have to physically you have to do, and someone is paralyzed but he has to go to the hospital to do the treatment, even if it is paralyzed. But now we have discovered a technique that is called virtual reality, where we need not to go to hospital, and it is incorporated with the GenAI. So how the GenAI will have? Yes, whatever you have a queries in our headset, okay, we will design the model with the system which is based on the Unity, okay. We'll design a virtual environment. So sir, how the virtual environment? Yes, the virtual environment is like, suppose someone is, this hand is paralyzed, okay. So it will have different kind of exercises he will do. He will wear the headset, okay, and he will feel that he is there, okay, virtually he is there, and there is a chopping is there, and he will doing like this, and at the same time he will enjoy, and the exercise is also happening. And you will surprised to know that if he taken, like, knife, that weight also he will feel. That means whatever he will do the exercises at hospital, he will has to wear the headset and he will feel the same thing, and by this his improvement would be taking place. And that report also would be automatically generated by the help of GenAI, and that will also be stored in the cloud. That means the patient would also able to know how much improvement has been taking place. Now the next time his exercise would be changed. He may not have to do the same exercise. Now he has to do some simple exercise than that one, or he has to pull some ball, okay. So in this way, when the different exercises are there and his health part is also being improved, he will also enjoy, and the reports are also being generated by the GenAI, so that, sorry. Okay, so we'll see little more about this. I have told you the briefly because we have also done in this, and we have also filed a patent, and it has also been published. So if you are being interested, you can contact me. So now, okay, so here we are integrating virtual reality with AI in healthcare, integration of immersive environment for cognitive activity. Okay, so like as I have told, different type of activities we need not to do. We'll simply rely on your VR headset and the generative AI, and yeah, using AI and VR tracking for addressing inversion tools, and using then yeah, here we are using this Mocha and the FIM to keep track of patient progress. So how to keep the track of this progress? We are using these two tools, okay, Mocha and the FIM. So this is the generalized way. The user has wear a headset, and he transfer his data to the cloud server, and there is a generative AI is there, and it will transfer into the terminal, and it is connected with this. So as I have told you, you have to wear an headset, and it is already been fixed with your connected with the Wi-Fi. Yes, it must be connected with your Wi-Fi so that you can connect with the cloud, okay. And whatever the experiment you will do by using the Unity with your system, and those reports would be generated and stored into those reports will be generated by the help of AIs, and that will be stored into your system, okay. Anytime you can able to store from the cloud or from your system. So this way you can get a better treatment, okay. So this is just an example I have given, like how you can able to do the visual scale. Like we created a 3D environment. I hope you know, by using this headset, okay, you can able to create the 3D environment, okay. So this is one application that we have done in our lab. You can see that, and we can see that MOCA. So MOCA means, yeah, experimental Montreal Cognitive Assessment MOCA, baseline assessment neurocognitive protocols with dynamic virtual simulation to evaluate the user's cognitive capacity. So it will be helps to do dynamic uh, neurocognitive, okay, dynamic performance, okay, and FIM evaluates recovery progress clinically with the FIM to enhance validity of the recovery progress. So FIM will helps to see the reports, like day by day how the improvement has been taking place. This is just simply a result. You can see when the MOCA score is less, we are getting result level is easy. When it has been increasing, it is will be challenging, and the accuracy you can see when it is like MOCA score is less, that means it is very easy level, and when it has been increasing, it is a very difficult level, and these are the times it will take to get this accuracy, okay. So these are all about like how we have done the experiment, and MOCA and FIM helps to track the progress of the experiment, like the progress of the patient, how it is being taking place, okay. So the same thing, and the experimental application of behavior with generative AI. So generative AI helps to convert the text into speech and the speech into also text. So that is just an example. And now this is the results which we have generated. You can see MOCA score, the same results you can see here by doing the experiment. So how are feeling now? Is feeling good. So yeah. So now this, yeah, this is all. And the finally we have just given one, because we should have a healthy diet so that we should not fall into those diseases. That's why I put the last one. It is called NutriVision. Okay, NutriVision also we have used, like we have taken how we have. I hope many of you have done this work. How many of you know about like what should be your health diet? Okay, so that you should not fall away. Okay, so now what is our application here? It will do the NutriVision. We have worked into NutriVision 1 and NutriVision 2.0. Okay, 1.0 and 2.0. So 1.0 what we have done, okay, let me tell is a 1.0 I have explained here. So when we taken a photo, photo will be taken, we'll find out what is the object, and food quantification means like what are the different components, what is the carbohydrate, fats, proteins and sugar, and nutritional estimation, like here we are finding what is the nutrition it is, and nutritional analysis. So here you can see we have also taken the two food items what we have this chatbot. What are the, based on your health, what are the food you needs to recommend it? Suppose someone is having diabetic, so it will recommend, sir, I am having a diabetic, so chatbot will give you a recommendation. Yes, you should take these kind of foods like oats, idli, broccoli, walnut, masala. So that we have created here. A part of this, you can see here this chatbot. Yeah, we can also this chatbot. What should be the basal the BMI? Okay, what should be the BMI of a common human being? That also is being. If you can ask, he will give you the answer. Okay, and here you can see. Suppose you are, as I have told, suppose someone is having a diabetic, so he will suggest you, so I am having a diabetic, so what type of food I should take? So he will low carbohydrate foods, he will give you the menu, and also it will show you the menu, like what would be what should be the recipe, so that we can able to prepare based on that. Okay, and suppose someone is having like high protein, so need some to gain some weight, so he will also suggest like what are the high proteins you should able to take. Okay, like this we have several questions you can ask to your chatbot we have created, and accordingly he will give you to maintain your BMI. Okay, so these are all about we have discussed about so far, like NutriVision, the final one. So the future of smart healthcare lies in building intelligent, adaptive and reliable AI system that not only predict outcomes but also personalized decisions for improved human being. So that is my suggestion to all of you. Please maintains the healthy diets so that you will become healthy. If you are healthy, then only you can work on all those areas. So health is very, very important, and for that you can also make your own healthy chats like chatbot, and you can accordingly work on that. And this is my suggestion: to become healthy is very, very important, which is being neglected by in the student life. Then after that we realize when we'll be like more matured. So please be healthy. Okay. Thank you. And last one, yeah, this is my scanner. If you want to go and search my my publication details and all these things are being here. So you please go, and if you have any query, you can send me a mail also. I'll be very happy that my BTech now under my guidance, BTech students, like every year 20 to 30 students, they are working with URP capstone project and all, and there are 2 to 3 students always they are with me to support, and I'll be happy that if you have any query and I can help you regarding the same. Thank you. Yeah, thank you.
Thank you, sir, for your wonderful speech. We appreciate your time and effort in making today's event a success. Thank you so much.
Okay, thank you. So can you have it as a common picture with all? Thank you, sir. Thank you, sir. Can you have it? Sir, good evening, sir. ठीक है, sir.
Very good.
Thank you, sir. Thank you, sir. हाँ sir, आपने से देखा ही था conclave रे. Can we have one group pictures if you all students?
Okay, thanks for Dr. Pradhan for this nice presentation. And we have discussed many things before this.
Because of the time, the last few parts